Good morning, students. I am Professor P.P. Dharmani from Mechanical Department IITM Belagavi. I welcome you for the course of Material Science. In the last class, we had discussed about the fundamental concept of unit cell. So basically, what is unit cell? Unit cell it is a smallest repetitive block in a crystal structure. Here you can see this box. We can call it as a unit cell. So any material, if you consider inside that material, there are there is a crystal structure. That crystal structure, which is made up of n number of unit cells. Here you can see this is the one unit cell. So in this way, n number of unit cells are inside that crystal structure. N number it may be a millions or more than millions of unit cells are arranged in a particular crystal structure. So the structure of that unit cell may be a cubic or it may be a non-cubic or we can say it is a tetragonal. Here in this case, it is a cube. The unit cell shape is a cube. To that cube, the atoms are arranged to the each corner of the unit cell. So at this corner, one atom will be present. At this corner, one atom will be present. And at this corner, one atom will be present. So for 8 corners, you can see 8 number of atoms are arranged in a unit cell. So in a similar way, the shape of the unit cell will be different types, which are basically 7 types of cubic systems you can see. So first one is cubic. In cubic, it is again classified as simple cubic, body-centered cubic, face-centered cubic, and simple tetragonal. These are the four basic types of crystal system. See, these are already we have discussed in the last class about simple cubic, body-centered cubic, face-centered cubic, and that is basically end-centered cubic. So in simple cubic, what happens? For 8 corners of the unit cells, one atom will be present. For 8 corners of the, this is one corner, this is one corner. In the same way, for all the corners, you can see 8 atoms. But in simple cubic, for body-centered cubic, other than 8 corners, one at the center of this cube, one at the center of the cube, you can see the atom at the center. So that type of unit cell we call it as a body centered cube. In the same way, for face centered cube, for 6 faces of the cube, the atoms will be present. For example, anyhow by default you can see 8 atoms at the each corner, one at this corner, uh, one at this corner, one at this corner, one at this corner. In the same way, in the face centered cubic, for 6 faces, this is side face 1, this is side face 2, and this is top face 1, and this is a bottom face 1, and this is a front face 1, and this is back face 1. So in this way, here totally you can see 8 corner atoms plus 6 atoms. This center one is for body centered cubic. It is not, we are not going to consider here. For face centered cubic, it is 8 plus 6. In the same way, for end centered cubic, uh, there are only 2 atoms are present apart from the 8 corners. For every unit cells, default there will be 8 atoms, But in end-centered cubic, the atoms will be either either to this wall or to this wall. So two atoms are present opposite to each other, or one atom at the top or one atom at the bottom. So such type of unit cell we call it as a end face, end cubic center. So these are the four different classification of cubic cells. So one, if in the examination, if you get the questions like write the seven crystal systems. So what are those seven crystal systems? So first one is cubic crystal. First one is a cubic unit cell, and second is the tetragonal. Third one is orthorhombic. Fourth one is rhombohedral. Fifth one is hexagonal, and sixth one is monoclinic, and seventh one is triclinic. So what is difference between a basic cubic unit cell and tetragonal cells, or whatever the seven unit cells? The difference is only the position of the unit cell, or angle of the angle of the unit cell. Here you can this is just a simple unit cell. Here this line will be treating as a x-axis line, and this line will be treating it as a y-axis line. Sorry, this line will be treating it as a z-axis, and this one will be the y-axis. So here we are going to measure the dimension of the unit cell by taking an example from this position to this position, from this position to this position. We are calling it as a B. We are defining it as a B, and from this point to this point, we are defining it as A. This is the length. We are going to define it as A, and this is the breadth. We are going to define it as B, and this is the height. This is the height from this point to this point. We are going to call it as a C. This point we are going to call it as C. So in this way we define the unit cell with the different dimensions. In the meanwhile, you can see also the atoms which are arranged with different angles. The angles are also created in or angles can be observed in unit cells. One is alpha angle. From this to this is alpha angle, and from this to this it is a beta, and from this to this it is gamma. So in this way, alpha, beta, gamma angles are taken place inside this unit cell. So these are the four basic unit cells of our cubic cells, and remaining tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and triclinic. These are the seven crystal systems. For cubic cells, what happens? The angle is equal. The angle is between this alpha, beta, and gamma. The angle will be 90 degree. But for other tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and triclinic, the angles will be different. Those angles you just refer a textbook. In that textbook, you will get more information about this angle. So when you in the examination, if they ask you write about the crystal section, then you have to write these seven cubic unit cells. But in the exam, if they ask about Bravais lattices, what are Bravais lattices? Bravais lattices are the subsystem of this crystal system, or there are In Bravais lattice, there are totally 14 types of unit cells you can see. It means inside the crystal structure of a material, in 14 ways atoms can be arranged. The basic one is 7 types, as I said, crystals. There are the basic common types of atoms can be arranged in a crystal structure, as I informed you, cubic, tetragonal, orthorhombic, etc. So in that shape, the atoms can be arranged. Apart from that, when a Bravais lattice, there are furthermore 14 shapes can be seen in the crystal structure. Those are: one is simple cubic, body centered cubic, face centered cubic, simple tetragonal, body centered tetragonal, simple orthorhombic, and end centered orthorhombic, body centered orthorhombic, face centered orthorhombic, simple rhombohedral, hexagonal closed packed, and simple monoclinic, end centered monoclinic, and simple triclinic. These are the 14 Bravais lattices. Okay, so whatsoever we discovered just now, this is all about ideal crystal. It means inside any material, we imagined that all the crystals which are arranged in a regular form. That's what we are imagined so far. But in reality, it is not going to exist. The scenario is different. The atoms, the crystal structure inside the material, there is a chance of deviating of atoms inside the crystal structure. It is not mandatory that all the crystals inside the material are perfect. There also possibility of getting a defects in the crystals. So which type of defects are there in the crystals? That is what we are going to study in a today's class. That is defects in crystals.